complete and total transparency, we just joined, what did we say, 3 days ago, 4 days ago, because we didn't know. And so I'm glad that all of you, how many are actual members of the caucus here, or represent offices of the caucus? Okay, that's not enough. Y'all need to sign up. When I speak to groups back home, I tell people all the time, the things that make America great are the things that America makes. Let that sink in. So from a manufacturing perspective, that's extremely valuable and important. But y'all didn't come here to hear a sermon, so I'll get off the manufacturing part. I want to say thank y'all for being here. I want to thank the two co-chairs of the caucus for hosting this event. I know that Mr. Reed couldn't be here. I want to thank Administrator Bridenstine for being here, him and his Mountain Dew, and it's a diet Mountain Dew, so he's being very careful. And I served 4 years with Jim, and we had a lot of fun on the science committee. And I want to thank you, Jim, personally, for your role and coming here to speak on the role of countless things that NASA does and the manufacturing, all the industry partners do. It is important. You're going to see this impact completely across the United States. In the Republican conference this morning, Vice President Mike Pence was there. He actually talked about the role, some of the things Space Force is going to play. So good things are happening. And along those lines, the Trump administration has sought to reinvigorate the United States space program, reestablishing the National Space Council under the leadership of Mike Pence. Next year, we'll be launching American astronauts from the U.S. soil for the first time since what year? Anybody know? 2011. That is huge, absolutely huge. America's rocket, the Space Launch System, aka SLS, the Orion spacecraft, and the lunar architecture currently in development will allow Americans to return to the moon for science, research, and preparation for future deep space missions. So this is important stuff. Now, back when Jim was a member of Congress, just a lowly member like us, I had the honor of serving along him on the House Science Committee. We sat side by side as fate had it, and Jim's got a great sense of humor. It has to put up with me. Right? So, y'all know that. It has to put up with some of y'all too. So, we had a great time there, and he's very smart on this stuff. He's got a great sense of humor, and more than that, he's got a passion for this. If you hadn't spent any time with Jim Bridenstine, trust me, get around him and let him show that to you. But for those of you who may not know, when Jim and I had a little lull in the action there on the science committee, we were known to play a game of hangman. Hangman. How many of y'all know what hangman is? Y'all are all young, right? Oh, y'all do know. Y'all do know. I always won. Because my word, he finally figured out, was supercalifragilisticexpialidocious. See? And so it's kind of tough for him to spell that. Well, we all know space is hard. And what did President Kennedy say? We choose to go to the moon, not because it's easy, but because it's hard. I could not think of a better person to come to the challenge than that gentleman sitting right there. And I've worked side by side with him for over 4 years now, 2, I guess, going forward where you are now, 2 more. So I look forward to attending the Artemis Day at NASA's Michoud Assembly Facility in New Orleans. How many have been to New Orleans? Some of you, sure. And we're going to see NASA's Space Launch System, the most powerful rocket since Saturn V. It offers more payload mass, more volume capability, and energy to speed missions through deep space. Currently, SLS's fully assembled core stage awaits her final test right down the road in Mississippi at the Stennis Space Center. So I'm sure, Jim, you'll be happy to elaborate about that. You'll do a lot better job than I do. So, before I wrap up, I wanted to leave you with a quote by Apollo 15 astronaut David Scott. I'll do that at the very end, but I'm going to have a quiz now. How many of y'all know what happened what NASA did on this day in 1965? Anybody? Say again? Mercury. In 1965, the United States launched Gemini 7. See, I'm trying to remember all those names too. going back a ways, with Air Force Lieutenant Colonel Frank Borman and Navy Commander Jim Lovell. Does that name sound familiar? Jim Lovell. Oh, you bet. And then in 1973, the Pioneer 10 reached Jupiter. So great things are happening, and you can go back and you can look at that stuff in history and understand that. Well, back to David Scott. It was 1971, and Apollo 15 Commander David Scott radioed to ground control at Johnson Space Center in Houston, Texas, about 20 miles from where I grew up, from his spot near one of the moon's valleys, Hadley Rill. And this is what Scott said, and I'm quoting, "There's a fundamental truth to our nature. Man must explore, and this is exploration at its greatest," end quote. Folks, there's no more higher ground than space. This is extremely important for us. So that was Commander David Scott, Apollo 15. So I want to begin to close by saying thank you all for being here. We're thank the administrator. I will say this about NASA. I coined the phrase. I call it, we're bringing together bipartisan. This is bipartisanship. We're bringing everybody together. You're seeing Democrats, Republicans, Independents, Conservatives, Liberals, whatever. Everybody work together on this behalf. NASA is leading that charge. I call it American Togetherism. My staff said, that's not a word. I said, it is now. So, and then today as I came here thinking about the manufacturing caucus, I thought, you know what? Here's another good phrase. Together we can make things work. So, thank y'all all for being here. Jim, it's an honor to introduce you. Come talk to us.
Thank you, Randy. Is this thing working? All right. Thank you for that introduction, Randy. I was not anticipating you telling everybody we used to play hangman on the committee, but that's okay. I guess it's just a little truth that we have to live with nowadays. I will also say, Don Norcross, it's great to see you again. Like you said, this does bring people together. When I was going through my confirmation process, I had to go through the Senate. I went to a few of my friends that I worked with on space issues, on the Armed Services Committee, on the Science Committee, and I said, hey, would you guys be willing to sign on? We had a dozen or so Democrats sign on to a letter supporting my confirmation for NASA administrator. And Don, you were one of those. I remember it. You're a good friend, and I appreciate that. This is not political. You're talking about bringing people together. I want to share, kind of the history. And of course, you shared a lot as well. But remember where we were when we landed on the moon in 1969. This country was completely divided. We had the war in Vietnam was at its peak. We had 50,000 people a year being killed in a foreign land. Maybe it wasn't a year, but it was a lot. 50,000 plus total. We talk about we had civil rights abuses. We had civil rights protests. We had riots on college campuses. It was just a bad time in the United States of America. But here we were, July 20th, 1969, and because we had bipartisan support for this very unique objective to land a person on the moon, this year we celebrated the 50th anniversary of the Apollo 11 moon landing. And this year we saw 500,000 people out on the National Mall. And I know we as members of Congress, we have seen 500,000 people in the National Mall before. They're never happy. In this case, they were all happy. And they were Republicans and they were Democrats, they were independents. It was apolitical, it was bipartisan, and in fact it was international. And to see that on the National Mall on July 20th, 50 years after the event. So the question is this. What we did back then at a very divisive time, bringing America together, bringing the world together. When we landed on the moon, who did we get congratulations from? We got congratulations from the Soviet Union. We got congratulations from Cuba. These were very difficult relationships in those days. And yet at that time, the whole world united and said, that was amazing. So what we have to think about now is what are we doing today that 50 years from now People are going to be celebrating what we in this room put together and achieved. That's what we need to be thinking about. And there's a lot that we can be talking about right now. But the biggest program, the thing that we have set up behind me, is the Artemis program. The Artemis program is about, it's a number of things. But the number one thing is to return to the moon sustainably. We do not want to repeat Apollo. We want to go back to the moon, but we want to stay. We want to go with commercial partners, which drives down cost and increases access. We want to go with international partners. We want to build a coalition of nations so that we can all go together and all do more than any one country could do alone. This is an amazing tool of diplomacy for the United States of America. So these are great capabilities that NASA brings to the table. We're going to go to the moon sustainably. We're going to go with commercial partners. We're going to go with international partners. We're going to utilize what we discovered in 2009 for really the first time. Hundreds of millions of tons of water ice on the south pole of the moon. Water ice represent hundreds of millions of tons. We're talking about life support. Water ice is air to breathe. It's oxygen. It's water to drink. It's H2O. And when you talk about cracking H2O into hydrogen and oxygen, the hydrogen is rocket fuel. Hundreds of millions of tons of rocket fuel on the south pole of the moon. So we need to utilize that. But we've got to get to it. We need to characterize where it is, how it's embedded in the regolith. You know, that it's in craters, it's in the dark spots on the south pole of the moon. How do we get to it? How do we get access to it? And how do we utilize it? And then what we need to do is we need to take this knowledge and information. We need to learn how to live and work on another world for long periods of time for a reason. Because we want to go to Mars. And there's a lot of reasons to go to Mars. And this is another thing that we all need to be united around. Just since I've been the NASA administrator for the last year and a half, this is what's recently been discovered. There are complex organic compounds all over the surface of Mars. The building blocks for life, in fact, exist. That's what I'm talking about. All over the surface of Mars. They don't exist on the moon at all, zero, but they're all over Mars. We have on the surface of Mars, we found liquid water 12 kilometers under the surface of Mars. What do we know about liquid water on Earth? Wherever there's liquid water on Earth, there's life. Is that true on Mars? I don't know. But under 12 kilometers under the surface is protected from the radiation of deep space. The other thing that's important is we found that the methane cycles of Mars match the seasons of Mars. Does that mean that there's life there? No, it doesn't necessarily mean that. Here's what I'm telling you. It could be geological in nature. But what I'm telling you is the probability for finding life on another world is increasing, significantly increasing. I'm the NASA administrator, so I'm not going to make any announcements until we make a discovery. But the probability is going up. I'm not telling you we're going to find bunny rabbits, but what we could find microbial life under the surface of Mars. We could. And here's the thing, when that discovery is made, it is going to absolutely add chapters to science books and history books. I grew up, look, I'm the first NASA administrator in history that doesn't have a memory of where he was when we landed on the moon in 1969. I don't have a memory of where I was when we landed on the moon in 1972, the last time we were on the moon. I wasn't born yet. I'm the first guy that wasn't born when these events took place. That is a problem. We need to fix that. We need a new generation to rise up and say, we're going to continue exploring space in a big way. We're going to send humans further into the solar system than ever before. But because of the technology that exists today, the miniaturization of electronics, the reusability of rockets, the ability to store power in much more dense capacities, the computing power, I mean, think about your cell phone. Has, I don't know how many billions of times more computing power than we had in the Apollo program, but a lot, or just a ton more in your cell phone. You add up all these things, you say, look, we can do this. We can go to the moon sustainably. We can learn how to live and work on another world. We can go to Mars. We can achieve these objectives. Now, are they going to happen overnight? No. But are they achievable in our lifetimes? Yes, especially looking around this room. Eminently achievable in your lifetimes. There's a lot of young folks here. And that's a great thing. You know, I have been clear that when we go to the moon this time, in fact, this isn't me being clear, this is the direction that I have from the administration. When we go to the moon this time, the next man and the first woman on the moon are going to be Americans. And we're going to do it leading a coalition of nations, enabling them to also have their first man and their first woman on the surface of the moon. So we think back to the Apollo era. In the Apollo era, all of our pilots, all of our astronauts came from a fighter pilot background or a test pilot background. And in those days, there were no opportunities for women. Just didn't exist. But today we have this very diverse, highly qualified astronaut corps that includes women. And when we look at Greek mythology, I want to be clear, we love the Apollo program. We're very proud of the Apollo program. But when we look at Greek mythology, look at who Apollo was. He had a twin sister. His twin sister, her name was Artemis. And she was the goddess of the moon. This time when we go to the moon with a very diverse, highly qualified astronaut corps, this time when we go to the moon with the first time ever with a woman, we're going under the name Artemis, the twin sister of Apollo. And I think that just amazingly suitcases who we are as America, how things are changing, how things are improving, how we're more inclusive and we're moving forward in a very positive way, a way that unites us. That's what NASA uniquely brings. And I'm grateful we don't regulate things. We explore, we discover, we do science and technology. And so these are things that we're developing right now. Now, I know this is the manufacturing caucus. Randy mentioned a few of these things. I should say Congressman Weber mentioned a few of these things.
Yeah, right.
a couple of things. We look at what's under development right now. He mentioned that we're going to launch, for the first time since 2011, we're going to launch American astronauts on American rockets from American soil. This is possible because we have had really 10 years of sustainable development at a flat budget. And when you develop things on a flat budget, it takes longer. It in fact costs more. But that's where we are. As a nation, that's where we are for a lot of the programs that DoD does and NASA does. But we're on the cusp here of being able to do that within the first part of next year. And we've got two suppliers that are looking at doing it. One is Boeing with a ULA rocket. So it's a Boeing ULA kind of partnership. The other is SpaceX. Those are American manufacturing jobs. So we're launching American rockets from American soil, but we're doing it with the manufacturing base that is available in this country. Quite frankly, with the science base and the engineering base that is in this country as well. These are capabilities that are important for the United States of America to be able to continue moving forward. We want to lead, and I want to be clear. We want to go with international partners, but we also want to lead. So when we do these things, we also have, right now, going to the space station, we have commercial resupply already underway. Going to the space station now over a dozen times, and we've got two suppliers there. One is Northrop Grumman, and the other one is SpaceX. Again, manufacturing capability right here in the United States of America. And when we talk about going to the moon, we're building the most powerful rocket in the history of the United States of America. In fact, the history of the world, the SLS rocket, Space Launch System. And this is going to be the rocket that goes all the way to the moon. The rocket itself doesn't, but it has enough throw weight to take our capsule with 4 astronauts all the way to the vicinity of the moon, where our astronauts will get into a space station in orbit around the moon. We call it Gateway, being manufactured by American companies. And that Gateway is going to be a space station where our astronauts can go from the crew capsule, the Orion crew capsule, built in the United States of America. They can get into the Gateway, built mostly in the United States of America. There is an international partnership when we talk about an international habitation module on the Gateway. And then they're going to get into a landing system. And of course, we've got a lot of companies right now that are bidding on how to build this landing system to get our astronauts to the surface of the moon and then back to the Gateway where they can get back into the Orion crew capsule and fly back to Earth. The architecture, the key to the architecture is long-term sustainability. You look at Apollo, every rocket, the entire system got thrown away. There's only one thing that came back to Earth, and that was that crew capsule at the very top, the triangle thing. And when that thing came back, it ended up in a museum. Even it was not reusable. So you could argue that it too got thrown away, although we get to see them in museums today. Today, we have an opportunity to build more reusability. The gateway, think of it as a reusable command module in orbit around the moon that's maneuverable. Another new thing. 15 years, we're going to have a command module that's got solar electric propulsion built in the United States of America, and it's going to go to the North Pole, it's going to go to the South Pole of the moon, it's going to give us more access to more parts of the moon than ever before. Why is that important? Think back to 1969, 1970, 1971, 1972. 6 missions, 12 people on the surface of the moon. And from those days until 2009, most scientists believed that the moon was bone dry because we went to the equatorial regions. 2009, 40 years later, we make this amazing discovery that there's water ice all over the South Pole of the moon. How did we miss that? Well, it's because we didn't go to all of the moon. We went to just key points. The gateway gives us access to the entirety of the moon. Imagine, if you were to come to Earth for the first time, and you landed in Washington, D.C., and I come from Oklahoma. Imagine if you tried to believe that Oklahoma looked just like Washington, D.C., or maybe you come from Colorado, or New Jersey. Maybe you come from the Sahara Desert. Like, the world is different. Everywhere you go, it's different. And the moon is different, too. And it's absolutely fascinating and diverse. And yet, we made assessments based on where we went. And we had it wrong for 40 years. So we don't want to make that mistake again. But we also want to build an architecture that's sustainable, that can prove that we can live and work on another world, so that ultimately we can go to Mars. That's the objective. And I'll tell you, the discoveries on Mars are going to be amazing. So with that, I want to make sure that we leave it to questions. I want to hear from you. I know, if there are thoughts, concerns. I know it's manufacturing, but anything space related, I'm happy to answer. Done.
Well, Jim, it's good to see you again. We start with on services. And we look at an industrial base, whether it's defense or for NASA. And when I was a bit younger, one of the things that attracted me to the Mercury, Gemini, and Apollo missions were NASA techniques and what NASA learned and put out to the world. We continue to do that. But you do so in a neutral way. When we look at some of the challenges we're facing as a country, as a world, climate, and other things, you play such a vital role, but nobody looks at you as a player either in one area or another.
That's right.
What do you see going on in the future?
Don, thank you so much for bringing that up. The question was focused on, being a neutral player and not being perceived as, one side or the other, and climate specifically. The tech briefs that we give to members of Congress and others. Here's the thing that is important to note. A couple of things that every scientist I encounter, regardless of what side of the aisle you're on or not, they will tell you, and I've seen the data, and I agree with that. Carbon dioxide is a greenhouse gas. That's just the reality. And there is more of it in the atmosphere now than ever before because humans have put it into the atmosphere. That's without question as well. And because of that, the Earth's climate has changed. That is also without question. What NASA does is we study it. And we're learning all kinds of things that are absolutely fascinating. So carbon dioxide is a greenhouse gas. It also enables plants to thrive. So we're seeing a lot of places around the Earth. In fact, globally, we're seeing a greening of the Earth. So the greening of the Earth ultimately has a cooling effect on the planet. And so the question is that a feedback mechanism that could offset the warming? The other thing that's interesting is when we look at the Arctic ice, and I got in trouble on the armed services, and I got in trouble because you guys had an amendment, and you said, we want to know what is the DoD doing to deal with climate change and be prepared for how climate change affects national security. And I was one of just a few Republicans that stood up and said, I'm with the Democrats on this, and I'll tell you why. Because the Arctic ice, it's not there anymore. Which means me, I'm a Navy pilot by trade. The Navy's having to defend territory we never used to have to defend. And our enemies are operating in territory where they never used to be able to operate. We know things are changing. We can't stick our head in the sand, but we need to do a study to figure out how the DoD is going to deal with these and other types of activities. But what we find is that as the Arctic ice melts, the blue water absorbs more heat from the sun than the ice absorbs, which means there's a feedback mechanism that exacerbates the warming issue. We also know that the weather, when you have the temperature of the Earth goes up a little bit, then you get more water vapor in the atmosphere. And the water vapor is a very, very strong greenhouse gas. And that water vapor ultimately results in precipitation, rain, which has a cooling effect on the planet. And then there's the lithosphere, there's the hydrosphere, there's the cryosphere, the atmosphere. There's all these different spheres that NASA is studying to figure out what all these feedback mechanisms are. And I'll be honest, we don't know what we don't know yet. We have a lot to learn. So the Earth science budget of NASA is critically important. I will also say what NASA has to be careful of, and we're very careful on this, at least we are when I'm the leader. We have to follow the science very dispassionately. Because if we start delving into the politics, then we end up being divisive. And we don't want to be divisive. We want to be the purveyor of the data and the information. So we gather the data, we gather the information, and we share it with the entire world for free. And then we hope that policymakers can delve into the politics. We expect that. But we don't get in, I don't want me or NASA folks to make policy prescriptions based on what we're learning. That's for others. But what we do is dispassionately follow the science, we collect it, and we share it. Thank you for that question.
I'm going to ease out.
All right, brother. Hey, thanks. Good to see you. I'll wish you. Yeah. All right, hang on. Thank you. All right. More questions? Yes, sir.
Thank you for being here, Mr. Administrator. I was wondering if you could comment a little bit on the SLS and its manufacturing impact on the country, multi-state, and then secondly, how the large capacity of the Block 1B will enable some things to happen which actually are ultimately a partnership with our commercial partners as opposed to being a barrier or problem.
Yeah, so the SLS rocket, again, this is a big rocket. Most powerful rocket ever built. And it's the rocket that's going to take our astronauts to the moon. What we're working towards and what we think is in the realm of possibility, and in fact we're seeking funding for it, is within 5 years. What we're looking for is a rocket that can achieve what right now no other rocket can achieve. And by the way, we're on the 5-yard line, about to punch it in the end zone. We're going down to Mishu. I'm going down to Mishu here Monday to celebrate the fact that we now have basically a fully complete rocket with 4 engines integrated into the entirety of the rocket. It's still behind some scaffolding and those kind of things, but we want to have a day where we just celebrate the fact that we're expecting that over the Christmas holidays, it's going to come out of the Mishu assembly facility and go to testing. That's going to be a great day for the United States of America. But parts of this rocket, of course, are made all over the nation. And I'll tell you, as I travel around the nation as a NASA administrator, I hear about it, I see it. In fact, I didn't realize it until later in the game, but when I was in the House of Representatives, I had a number of manufacturers in my district that were building parts for the SLS rocket. So it is definitely a rocket that includes all of America. You mentioned specifically the Block 1B. That would be basically the SLS rocket with a more powerful upper stage. So the way we're building right now is we've got what's called the interim cryogenic propulsion stage. That ICPS gives us an opportunity to get to the moon, but it's not as optimal as it otherwise could be. So when you have an ICPS which doesn't have as much thrust capability, what we call delta V as in NASA, change in velocity, it doesn't have as much delta V. What it forces you to do is it forces you to launch into a very highly elliptical orbit in order to get as much energy as possible out of the rocket. Then when you go to the moon for your translunar injection, you have to fire that rocket when you're at perigee, which is the low part of the highly elliptical orbit. So when you're closest to the Earth, you're at the maximum velocity of your vehicle. That's when you have to fire your rocket to get to a translunar injection. When you're in that highly elliptical orbit and you're firing it down there at that very, I know this is maybe a little technical, but at the maximum velocity, when you're at what we call perigee, closest to the Earth in this highly elliptical orbit, what you end up doing is you fire and you can shoot out to the moon. The problem is, the moon has to be in a very specific spot relative to Earth when you hit that rocket. And if it's not in the right spot, it's not going to work. So that puts you in a position where your launch windows from Kennedy Space Center are limited. You've got 4 or 5 launch windows in any given month. And so if you roll out to the pad, and then something goes wrong, maybe it's a weather event, maybe it's a bird hazard, maybe the range isn't clear, nothing would ever be wrong with our rockets, of course, but maybe something is not just right, but then you have to roll the rocket off the pad. You got to roll it back into the assembly, the vertical assembly facility, the VAB, vertical assembly building, and then you have to get whatever is fixed. You have to recharge all of your fuels and your pressures, and then you got to roll back out. By that time, you might have missed 1 or 2 additional launch windows. Because remember, you have to fire your rocket at that precise time when you're in perigee and the moon is in the right spot. There's only a couple of times during any given month, I should say 4 or 5 times in a given month, when that happens. If we have the Block 1B, which I know some in this room are very interested in, if we have the Block 1B, what that means is instead of going to that highly elliptical orbit, we can go into a round orbit. And that round orbit means you can launch to the moon, you can do that translunar injection anytime you want. So it gives you, you don't have to wait on the next launch window, you don't have to worry about flexibility. When you go to the moon, you have flexibility, you've got it's safer for your astronauts, and it's a better, more appropriate way to build a system. We envision that will happen one day, and we're looking forward to it. And of course, if you can help with appropriations, we're grateful for it. Yes, ma'am.
Can you talk a little bit about the supply chain for these space manufacturers, and if you have any concerns about just ensuring that there's enough redundancy and options for supply chain?
Yeah, so the supply chain is unique when it comes to space because it's not like building cars where you're building for the entire country or the entire world. You're not mass producing, you're producing 1 or 2 at a time. A lot of private companies have taken their supply chain totally internal. In other words, they build every component themselves because what they're building is so unique that if they outsource it, even if they outsource it, whoever they outsource it to is going to have to build it themselves. We're talking about subcomponents to subcomponents to subcomponents, if you know what I mean. And then if they don't get it right, then it has to be redone, cost goes up, schedule gets delayed. These are challenges in the supply chain for the space business in general because of how unique what we do actually is. So a lot of the private companies have said we're going to bring it in-house. Some of the more traditional companies that want to make sure that certainly people in Oklahoma are being employed in the whole process, they do it very differently. They create very specific specifications, and then those specifications have to be met. If they don't get met, then it doesn't go on the rocket. So there are different ways of trying to make sure that the supply chain is there, but it's a challenge. Whether you bring it in-house or you do it out of shop, it's still a challenge. It's a challenge for everybody. But as we do more and more launch activities, which we anticipate we're going to see, not necessarily because of NASA, but because of DoD and because of the commercial space industry, we've got constellations of thousands of satellites that are going to be launched to low Earth orbit for space-based communications. And when those kind of things happen, the launch cadence goes up, costs go down, those kind of things. But for those activities, I think the supply chain is going to get more normalized. For the very unique missions that NASA does, there's no commercial market to go to the moon right now. There's no commercial market to go to Mars. Those are projects that NASA is going to have to take on itself. And when we take those on, yes, we're going to have supply chain issues. It results sometimes in cost overruns, schedule delays. But we have to take that on ahead of time and be very diligent about it. It's a good question. It's never an easy answer. We'll go here and then here.
To follow up, I'm wondering if you can comment, Mr. Administrator, both on some of the technologies being developed for the Artemis program, and also if you foresee any synergies with the existing industrial base, particularly with DoD.
Absolutely. So Artemis specifically, we got this really big rocket, the SLS rocket. We're using RS-25 engines, which are basically remanufactured space shuttle main engines. So that's a cost saver. And so but they have digital electronic control. So I would say they're far superior to the space shuttle engines because they have that digital control. In other words, the fluids that go to them are very, very specific and they can change, and it's all done by a very, very fast computer. It's the same technology, quite frankly. I'm a Navy pilot by training. Same technology that we use on military aircraft. We're just using it on rockets now in a more robust way. So that's kind of a new technology. When we talk about getting to the moon, the Orion crew capsule, we're gonna make an effort by Paul, how are you?
Doing good, Jim. How about
Thank you
yourself?
for coming. Good. By the time we get to the 4th Artemis mission, we want to have the Orion crew capsule being reused. So the first pressure vessel will be reused by the 4th one. I'm not saying this is going to happen, but this is what we're shooting for. And then we can reuse maybe some of the avionics on board. And as time goes on, we're going to learn how much of this crew capsule can be reused over and over again. So it's not like the Apollo program. That's a very expensive device. So if we can start reusing capabilities there, that's critical. On the Gateway, the space station in orbit around the moon, it's the reusable command module in orbit that has solar electric propulsion. That's a new technology. Now, solar electric propulsion is currently used for communication satellites in geostationary orbit, but it is also true that it's never been used at the scale we're talking about. We're talking about 50 watts of thrust from solar electric propulsion and aggregating that to get even more propulsion to move faster and go to different parts around the moon. So that's a new technology. We're going to have to build habitation modules that are compatible with the power and propulsion element with the solar electric propulsion. Those habitation modules are going to be for deeper space. So there's going to be some, in other words, we're going to need some more protection from the radiation environment. It's also true when you're in low Earth orbit, you can get home quickly. If something goes wrong, you can get in a capsule and you can come right home. That's not true at the moon. You've got a 3-day journey if you're going to come home. So we've got to make sure that we've built in some additional redundancy, some additional protections that might not have been necessary previously. And then when we go to the surface of the moon, this is the big thing that we need appropriations for right now. We've got to have a lander. If we don't have a lander, we're not going to get the first woman and the next man to the surface of the moon. That lander, we have a plan for it, but we don't have, at this point, we don't have the appropriations. We've got appropriations for everything else. So takeaway from me, just so you know, CRs are better than shutdowns, but we also, appropriations are way better than CRs, just so and I'm sure everybody here knows that. But if we get the appropriation done, then we'll have potentially, depending on what it comes out to be, potentially money to start the lander so that we can go as fast as possible. That lander is going to be reusable. And it could be multiple landers. And the glory of the Gateway, oh my gosh, there's so much to say. The glory of the Gateway around the moon is that it's open architecture. So the way we do docking, the way we do avionics, the way we do environmental control and life support, the way we do data, the way we do communications, all of that is available to the public on the internet. So if you're a small country in the world, maybe you're United Arab Emirates, and you want to have a mission to the moon, guess what? You can build a lander. And then you can partner with the United States of America that has this architecture that enables you to get your lander to the moon. And you can have your own mission to the moon. Maybe you're a private company, and you have an interest in finding out if, we talk about rare earth metals here on Earth. Rare earth metals are asteroid impacts. That's what they are, from billions of years ago. And they're trace. Why are they so trace? Because we have this very active geology, this very active atmosphere, very active hydrosphere, and so everything gets mushed up, and when you find it, it's like in small. Well, the moon doesn't have an active geology. No hydrosphere, no atmosphere. And so anything that impacted the moon billions of years ago is right where it was billions of years ago. And there could be large deposits of platinum group metals, rare earth metals. I'm not saying they're there. I don't know. But neither does anybody else. But I'll tell you this, one of these investment banks, I can't remember which one, recently did a study, and they said the world's first trillionaire will be somebody who figures out how to mine asteroids or how to mine the moon. And by the way, when you mine the moon, you're mining asteroids. Anyway, so you get my point. So we need to have reusable landers. We need to have the open architecture. These are brand new kind of thoughts on how we go about doing this. We bring in the international partners, we bring in the commercial partners, and then, but NASA, NASA's not going to explore for metals. That's not what we do. We're not trying to, what we want to do is we want to build infrastructure. We want to build the architecture that enables all of these activities to go forward, and then we can press from there. But if you look at what we're doing in low Earth orbit right now, we are working every day to be one customer. We want commercialization of low Earth orbit in its entirety. So NASA can be one customer of many customers in low Earth orbit, and we can have numerous providers that are competing for NASA's business, numerous providers competing on cost and innovation, driving down cost and increasing access. Now this is for human activity. Make no mistake, there is already a $400 billion commercial marketplace in space. It's dish network, satellite TV, it's XM radio, it's remote sensing imagery, the kind of things that you Google Maps, those kind of activities. There's tons of activities in space that are commercial in nature. It's a big industry. But there's no human activity. We want to see human activity extend into space commercially. And then NASA can take its resources that get appropriated by Congress, American taxpayer dollars. We can take those resources and we can do things for which commercial industry will not yet do. Go to the moon and on to Mars. So these are kind of our thoughts on these activities. But that's going to require innovation that NASA's not even thinking of right now. Because private companies are going to do all kinds of things. You're going to have private companies trying to get access to the water rights for the purpose of ultimately creating the rocket fuel that's going to enable NASA to go further. But it might not be NASA. It could be one of our international partners collaborating on the Gateway, on that space station in orbit around the moon. It could be others. The goal here is to enable more exploration than ever before, but to make sure that the United States of America is in the lead. We want collaboration, but we want to make sure we're in the lead. And that requires, I don't know if you've heard it yet, appropriation. Yes, sir. I'm sorry, I said over here. I apologize.
Well, I had one question, but after all that, I have two. The first one was, if you're going to have all this equipment up there, how will you handle maintenance? Do you envision manufacturing things in space, or is there going to be cargo ships going back and forth with repair parts?
It'll be both. So right now, NASA's making investments into, for example, manufacturing in space, 3D printing in space. These kind of things that are transformational for manufacturing here on Earth are even more transformational for manufacturing in space. So that's I think, one starting point. We're also investing into robotic servicing of satellites. So if you can robotically service a satellite, then you can robotically maybe manufacture. I should more use the word assemble. So we can launch smaller things and then make bigger things by doing assembly in space. NASA uniquely has the ability to assemble in space. The entire space station is, larger than a football field. And it was assembled over 20 years. And so but that was all done with spacewalks, with humans. Now we can actually do it with robotics and humans, and now we can do more than we could ever do before. So these are different ways of doing similar things. But the key is we have to create the market that creates the demand for those activities. So to create that market, we have to use the space station that exists right now today to create those breakthrough transformational capabilities for life on Earth. So right now on the International Space Station, we're proving, this is fascinating, we are proving that you can print human organs in 3D. When I say print human organs, I'm talking about adult stem cells, take adult stem cells, and you can create tissue in space. If you create that same tissue here on Earth, it just goes flat because of the gravity, and you can't escape the gravity on Earth. It can't be done. You can try, but it's never been done before. But in space where there's zero gravity, or I should say microgravity, you can grow 3 dimensions. Now, that means that there's life-saving capabilities. Another thing that we're able to compound pharmaceuticals in a microgravity environment in a way you can't do here on Earth. We're able to create immunizations in a microgravity that you can't do here on Earth. We're able to, one of the things that I like to talk about that I think is fascinating is advanced materials. So we can create artificial retinas using advanced materials for the human eyeball in space that you cannot create here on Earth, which means people who have macular degeneration in the future won't have to lose their eyesight. That's transformational. Imagine taking a box up to the space station that fits in the palm of your hand, and in it has all the materials to create 1,000 artificial retinas. And it goes up to the space station, it comes back down. And people who have macular degeneration, their surgery is reimbursed at $75,000 per. All of a sudden there's a massive market to do the manufacturing of those artificial retinas in space. And that's what creates, so the key is you got to have the demand for the transformational breakthroughs. Fiber optics, I think, is another very capable, it's a capability for the future of manufacturing in space. Because you can create very pristine, very pure, very clear fiber optics in space that you can't create here on Earth because of gravity. So once we master these things, I think we're probably 3 to 7 years away from just one transformational breakthrough where you're going to see private industry putting money into not just access to space, but space stations. And I think that's good for the future. Now, all of that is only possible because of what NASA has been doing today. The space station has made that possible. And NASA will always, always have a presence in low Earth orbit. We have a lot of work to do, I'm just telling you. We do experiments. We prove physics, we prove biology, we do experiments. We don't do manufacturing. We don't do, what we do is we prove the technology and the science, and then we license it to private industry, and then they can take it and they can grow it from there. So those are the kind of things that we're thinking about. Does that answer your question? Do you have another one?
I did have another one. If you open up this whole field to private industry in other countries, it seems like you'll need a whole new governance structure.
Yes.
And so what is the thinking in that direction?
Yeah, so this is a challenge. The most immediate challenge, of course, is debris. And debris is dangerous for humans. It's dangerous for satellites, but satellites don't have mothers, so it doesn't get the attention that it does for humans in space. So NASA, this is a job that is done by the Department of Defense, Space Situational Awareness and Space Traffic Management. It's a legacy for the Department of Defense that goes back to the day when only they were the ones that could do it. But I'll tell you, we're getting to the point now where we need an FAA for space, and we don't have it. The DoD does not want to be doing all of this activity for commercial and international partners. DoD needs to focus on what DoD does and not be the FAA for space. So the administration has put together what they call Space Policy Directive 3 that charges the Commerce Department to create a space situational awareness and space traffic management regime that would ultimately, again, the United States would lead, but you got to have international partners. Just like the FAA resulted in ICAO, International Civil Aviation Organization. So I, as a pilot, when I fly in Europe, I'm flying under all the same rules that I fly under when I'm in the United States. And everybody's speaking English, which makes it good for me because I don't speak any other languages. But the bottom line is there is a standard to fly around the world, and it matches what we do in the United States. Because we led that whole effort. We need to do the same thing in space. And Space Policy Directive 3 enables that to happen. Now, here in the House and in the Senate, there is some debate over whether it should be the Commerce Department that does that or the FAA that does that. That's what's holding us up. And I will tell you, I've said before, somebody needs to do it. We can be held up for the next 10 years arguing over who, and we're going to see collisions. Somebody needs to do it. I do believe it ought to be commerce, because I don't think we don't need regulation the way FAA regulates at this point. What we need is development. And we need commercialization, and we need, in my view, we need technology development to achieve that to begin with. But eventually, it'll be like air traffic management for space. It's a good question. Yes, sir.
Hi, Mr. Administrator. I want to thank you so much for speaking to us about all of this. It's incredibly fascinating. But how do you reconcile some of the many benefits from living in a micro-G environment, some of the health effects that can come about as a result of living in a micro-G environment? And then the follow-up question, we do know that the international public is
Yeah.
The same goes for China, and China space probe. Have there been any efforts by NASA or to potentially further broader international partnerships?
Absolutely. You bet. So a couple of things. Yes. Your first question. Tell me, remind me.
Low G.
Low G, yeah. So the human condition, of course, in microgravity, we're not designed for that. It's a real problem. You lose 1 to 3% of your bone mass every month. Your physiology, you get weaker, you lose your muscle mass. You can mitigate that with some working out, but you still have challenges. Your vestibular system kind of doesn't work the way it used to. You lose weight, significant amounts of weight. You're not as hungry. You have cranial pressure in your head. That results sometimes in what we call optic nerve edema. Your optic nerve swells. And there are astronauts that have permanent changes in vision because of it, not for the good, but for the bad. And that happens over a period of 3 to 6 months. When you go longer than that, it gets even worse. So your point is, the difference between microgravity and low gravity. And that's a key differentiator. This is why the moon is so important. Because in a microgravity environment, when you're just floating around in orbit around the Earth, that's where those effects come in. The question is, if you go to the moon, is that a countermeasure for all those negative effects? And I think the answer for a lot of it is yes. So we've been doing studies where we have subjects that are getting paid a lot of money, and they're doing it voluntarily, so make no mistake. But they're laying on their back at about a 5-degree incline towards their head. And what we find is that the same cranial pressure that gets developed in space happens when you basically lay on your back, 5 degrees head down, and you stay there for a long period of time. We're talking about weeks and months without moving. And so they have to eat on their back, laying flat on their back. If they lift their head up for just a minute or two every day, the countermeasure is there. In other words, the optic nerve edema doesn't happen. The cranial pressure is there, but there is an offset. So it doesn't take much gravity in order to do an offset. Now, I want to be clear, we're still studying all of these things. But this is why we need to go to the moon. The moon is the proving ground. The moon is how we learn how to live and work on another world. We learn about how does your immunity system gets degraded when you're in space. Does that happen when you're in a low gravity environment? So the moon is 1/6 the gravity of the Earth. Mars is 1/3. So if the moon is a mitigator, then Mars is definitely an even better mitigator. So we know if we can live on the moon in such and such way, based on it being a countermeasure because it has a gravity well, then we would also know that Mars is also a mitigator. So my point is this: we need to get to the surface of these destinations, not just going to orbit around them. And what was your next question?
Has there been any efforts by NASA to build a strong relationship with other space agencies and sustainable international partnerships?
Yes, and look, what we want to make sure we do, to be clear, because I know there might be some appropriators in the room, or at least appropriators for staffers. Staffers are appropriators. We want to make sure that we're not taking NASA's budget and outsourcing it to other nations. We want NASA's budget to be strong. We're not trying to cut it. But what we also want to do is we want to enable more exploration by having partners join with us. And so some people get concerned when I start talking about international that somehow we're going to cut NASA's budget. So that's not the goal. Our goal is to enable NASA to do more with partnerships around the world. And yes, we have right now, we've had experiments on the International Space Station from 103 different countries. We've had astronauts from 19 different countries. We have 15 nations that are part of the International Space Station, 15 nations that operate. We would love to see those, in fact, of those 15 nations, 14 of them are already committed to the Artemis program. I'm telling you, this is incredible. I'm talking about parliaments have passed bills. The European Space Agency just had their ministerial, and this was just last week, and they said, we're going to be with you on Artemis. Canada said, we're going to be with you on Artemis. Japan said, we're going to be with you. We have Australia has never had a space agency until a year ago, And they created a new space agency, gave it $150 million, and they said they want all of it allocated to Artemis. Australia is not a partner on the International Space Station. We partnered with them on other things, but not so the partnerships are growing. We're seeing new space agencies from countries like Luxembourg and, of course, United Arab Emirates and Greece. I mean, there's lots of countries that are popping up with space agencies that are brand new. Poland just started a space agency. So we have more opportunities to partner with more nations than ever before. And this gives us great hope. India has had a space agency, but we've never partnered with them on the station. But they want to go to the moon. So there's an opportunity there. Brazil, they're, again, not nearly as mature in space flight as others. In fact, they're not mature at all, but they want to be a part. We've had conversations with people over there. They haven't committed in the same way as some of the others. But there's a lot of opportunity out there. That here's what it requires. It requires us to lead. That's what it requires. There was a day in the United States where we retired the space shuttles and we canceled the replacement to the shuttle, the Constellation program. And what happened? All the partners started talking to China. That's where they went. Because China, they had their second space station underway, and now they've had 2 space stations. They don't have one right now, but they're building a third. And it's operated by the People's Liberation Army. It's operated by the military. All of their astronauts are military. They have a different philosophy, a different mindset. And we're prohibited by law from doing any kind of bilateral engagement with China on exploration. But the question is, who do we want leading these activities? Do we want it to be the United States, or do we want it to be somebody else? In my view, it ought to be us. Remember, whoever goes first makes the rules. And I know we look dysfunctional right now, but I like our rules better than their rules. All right, I'm getting the hook. I just want to say thank you.
I want to say we should thank you also
And tell Tim Ryan, thank you for having me.
We'll definitely will, and Tom Reed. So
Yeah.
thank you so much for your excellent talk, and just give him a round of applause, please.
Thank you.